So I said hash include iostream, then I'm going to say using namespace std, I'm going to put a semicolon. I'm going to say int main, and I'm going to give it that bracket. Then I'm going to open. So we are talking about integers. We are talking about integer as a primitive data type. So the integer as a primitive data type, basically what it does is it stores whole numbers. So in my comments here, I'm going to say stores whole numbers. So when I say it stores whole numbers, I'm basically talking about numbers like it can be from 0 stores whole numbers. It can be a 0. It can be either a positive. It can be a positive or a negative number. It can be a positive or a negative number. So when you want to store when you want to store a whole number, whether it's a positive or a negative number, you will use the data type integer. The number should not be a decimal. The number should not have decimal points. The number should not have decimal points. Those are the key things that you need to know about integers. They are data types that store whole numbers from 0. Okay, it can be 0 or any other positive number, as long as is a whole number, or even a negative number, as long as it is a whole number. So example can be, but even before I talk about the example, we need to learn a concept known as declaration. How we declare variables in C++. So that is variable declaration. So to declare a variable in C++, you give it the data type, and because it is integer in C++, we show it using int. So we say int. Let's say, for example, you want to store the age of a person. So we're going to say int age. That is a variable declaration. So I'm going to give a comment and say this is a declaration. This is a declaration. This is a declaration. So int age. Then we can assign a value into our variable. So we can say age is equal to, maybe I am 25. So we can say age is equal to 25. Now, so we have, in other words, we are trying to tell the computer, create a memory location, call that memory location age, then inside that memory location, store the value 25. So int age is a variable declaration. Age is equal to 25 is a variable, is an initialization. So here at line 9, we are telling the computer to create a memory location and call that memory location age. That memory location should be able to store variables of the data type. I should be able to store values of the data type integer. Okay, then age is equal to 25. We are storing 25 inside the memory location that we created. So line 10 is trying to store 25 inside the memory location that we created, that is age. So I want us to print age. So to print to the console, we use the command console out, which is cout. We use the command console out, then we have these less than signs here, then we have age there, then let's say return 0. I'll explain what return 0 means. In the meantime, your area of focus is the int age is equal to 25, and that printing message. Now if we want to run our program, this is just a simple program that is printing the age that we have written there. If you want to run our program, when you come here, you're going to see this first button. This one here is a compile button. This one here is a run button. This one here is a compile and run button. I need to explain a concept here that is very important, though I explained this concept in the previous classes. Now, C++ is a high-level programming language that requires a compilation. What we are writing here, this one is code in a human legible format. We are writing code in a human legible format. Code written in a human legible format or in a human legible language is actually known as source code. This is source code. Our computer is not able to understand this language. So we need to convert the source code into a language that the computer can understand. We call it machine language. So the process of converting source code to machine language is known as compilation, and we are using a compiler. So before we are able to run this code, we must compile it. Remember, we said this is one disadvantage, that every time we make changes on a program, we have to compile it. So if we come here and just click run, I want you to see what it's going to tell us. If you click run, I just want you to see something that is popping up here. You can see here, project is not compiled. Compile now. In other words, you cannot run the code until you have compiled it. So you cannot run that code until unless we have compiled it. So we can come here and compile. We can compile it. After we have clicked compile, remember that when we compile source code, what we get is bytecode, or we get the machine legible code. So it will require us to save. It will ask us to save that file. So I'll just save it untitled 2. I'll click save. Okay, there is a file that is called that way, so I'm just going to replace it. So it is going to compile. Once compilation is done, now I can run the program. Once compilation is done, it's still compiling. Yeah, it's done. So I can come here now and click run. Notice this time it will run. So when I click run, it is showing me here in my results. I hope you can see. It is showing me here 25. It is showing me 25. Why is it showing me 25? It is showing me 25 because here I am printing to the console the age 25. I am printing to the console the age 45. That is why it is showing me 25. Now, instead of first compiling the program, then running it, we have this button here that is provided for us. When you click this button, it can compile and run. Instead of clicking compile, then you click run, you can click this button to do the same things. First of the two things. First of all, it will compile the program. Then after it's done compiling the program, it is going to actually run the program. Now, our main area of focus here is integers. We said integers, they store whole numbers. It can be 0 or any other positive or negative number, as long as it does not have any decimal point. That is an integer. Now we said to declare the integer variable, it is declared in line 10, and we said int age, where int is the specification of the data type and age is the variable name. So we are telling the computer to create a memory location, call it age, and then in line 10 we are saying age is equal to 20. We are initializing age. We are assigning a value to age. So we are trying to say, look at the memory location that we created in line 9 called age, and inside that memory location store the value 25. Store the value 25. Now in line 11, console out age, we are printing the age. That's why when we print the age, you see the value 25. Now what I want you to know is that there are operations that can be done with integers. There are operations that we can do with integers. And the first operation that we can do with integer are the arithmetic operations. We can do addition with integers. We can do addition. We can do subtraction with integers. We can do subtractions with integers. We can do division with integers. We can do multiplication, multiplication with integers. I'm going to demonstrate how I'm going to show how we can do all that. Now, for example, we are writing a program to add two numbers. For example, we are writing a program to add two numbers. Okay, allow me just remove this, or we can just leave it there. We are writing a program to add two numbers. So let's declare two numbers. So we have int x, the first number is x, and the second number is y. So int x into y, int x into y. Then down here we want to add the two numbers. So let's say sum, int sum is given by so is equal to x plus y. So line 17, int sum is equal to x plus y. We are trying to add the two numbers. So let's print the results. So console out, we are printing the result sum. So console out sum. So if we run this program, remember, first of all, it is going to print this edge value here, because we still have this code here hatujaitoa, but again it is going to still print our sum here. But again, we have not given values to our x and y, so we need to give it value. So int x, let's say maybe x is equal to 20, and we say y probably is equal to 30. Let's say y is equal to 30. Yes. Now what I just did here, it's important that I bring it clearly. What I just did here is I declared and initialized at the same time. So when I say int x is equal to 20, int x is actually a declaration, is equal to 20 is an initialization. So you can declare and initialize variables at the same time or in the same line. So now we can come here and print our sum in line 18. So if we come here and compile this program and run, click compile and run. So we let the program. Now you see what is showing here. It's showing 2550, but that is not what we want. I will tell you why it's showing 2550. It's showing 2550 because here it's printing the edge, that is 25, but it is printing 25 on the same line, and here it's printing the sum of this, which is 50, on the same line. So we can use another thing here just to make sure we have this on a separate line. So we can put those less than sign, two less than sign, then we use the word NL. When you use NL means now we want to have it on a separate line. Just a moment, I take this call. Yes, Tony. Yes. Kama wanaitoa haina shida, we rudi tu, nitakuja nilipe. Nitakuja. Okay. Ebu waulize kama unaweza ikujia baadaye. Just ask them. Waulize kama unaweza iendea baadaye. Just ask them. Ama fanya hivi, waulize pia hiyo sheet namba ngapi yenye wametoa ndio nilipe kabisa, because time yako si inaisha. Nilipe kabisa. Just ask them. Niyo roka tu, roka 18. Haya, wacha nilipe. Watu ni wengi? Kuna watu wengi? We kama ni wengi sana, we muulize, mwambie nitakuja kuchukua baadaye, mwambie una rush class, utakuja kuichukua baadaye. Sawa? Mwambie tu hivyo. Okay. Sorry guys for that. So let's run this program and see. Let's run that program and see. the results again. So now you can see it's now printing on separate lines. So we have 25, and this 25 is because of this one here. This one we are printing the edge, yeah. Then the 50 is this one, the sum. So one thing that I was trying to show here is that we can do addition with integers. So this can be we can say addition. Okay, we can still do subtraction with integers. So we can do subtraction with integers. We can simply say maybe int difference is equal to y minus x. Int difference is equal to y minus x. So again, here I want us to print the difference. So console out difference. The difference of 30 and 20 should be 10. So if we run this again, if we run this, okay, there's an error. Okay, the naming issue. So we need to add an e there. So then we run that, we compile and run again. It is happening. Okay, int difference is equal to y minus x quote difference sorry. The spelling, let me just use some short term. Just use diff. Let's make some things simple here. Diff. Of course, when you're naming variables, you use variable names that are descriptive, that somebody will easily understand what that variable stores. So let me run that, and compile and run that. Now you see it's again printing 5010. Of course, the same issue. Let's come here and put because you want these results to be on separate lines. Let me just put NL here and L there, so that we have them on separate lines. Again, let me run it. So you should be able to print 10. Yeah, so the difference is 10. That is a subtraction. We can do subtraction with integers. Now the other thing that we can do with integers is multiplication. The other thing we can do with integers is multiplication. So for example, we can declare int mult, and we say int mult is equal to y times, or rather y times x, and then down here we print mult. Down here we print mult. Down here we print mult. So if we again come and run this program, so it should be able to show us. Okay, again we have 10600. We need to print this one, the difference, also in a new line. We have all of them in separate lines. You need to print that on a new line. So let's run that. So we have 600 as the multiplication. We have 600 as the product here. So line 25 is returning 600 because we are taking 20 times 30. Now the other operation that we can actually do with integers is division. Now most importantly, what I want you to know is that when we do division operations with integers, we get okay, at times we get, depending on the numbers that we are actually dividing, we can get decimal numbers. At times we get decimals. So if we get decimals, what is going to happen is the decimal value will either be rounded off. It will either be rounded off to a whole number, or it can be truncated. So it can either be rounded off to a whole number, or it can be truncated to make sure that we get an integer. Before it's stored there, it's either converted to a whole number or it's truncated. For example, let's divide 20 by 30. That is going to give us a decimal. So let's say int div, and we say is equal to x divided by y. Now in programming, we use that forward slash for division. So int div is equal to x divided by y. Then I want us to print the division results. So I want us to print div. Again, we're gonna have this on a new line. I want us to print div. So if let's run the program. If we come here and run this program, let's run our program. Now you can see it's showing 0 here. When you take 20 divided by 30, it's showing 0. Now the real results of 20 divided by 30, let me just open my calculator. The real results where is my calculator? Yeah, it's here. Let's check the real result. When you divide 20 by 30 using our desktop calculator here, so when I take 20 and I divide it by 30. I want you to see up here, it's 20 divided by 30. Then I hit the equal sign. Let's see the results. You are seeing 0.666666667. So what happens is it is showing us 0 because this value was actually truncated here. It was truncated. It was not rounded off. If it was rounded off, then it could show 1. So it was truncated. That value was truncated. And remember I said when we divide two numbers, or maybe when we divide numbers that are integers, when we divide integers and we obtain decimals, two things can happen. One, either the result can be rounded off to a whole number, or it can be truncated. So guys, that's it about the integer variable. That's it about the integer variable. Unless there's a question, I want to move to the next variable. Is there any question, guys? Any question?
No question.
Were you able to write those pieces of code? Were you able to follow them up?
No.
Why Rukia?
Kwangu imenitoa.
You have
Mimi
an
kwangu
issue. You
imenitoa.
have an issue with your machine. Okay, did you install the dev C++? Did you install the dev C++?
Yeah, I have it here.
You have it.
Yes.
So okay, I want you to follow up in the next
it.
variable that we're going to talk about. The next data type. Joshua, you okay?
Tutaanza kama new project.
Joshua, you okay?
Yeah.
Nice, that's great. So let's continue. Allow me to share my screen so that we go to the next data type. The next data type that I want us to talk about is the character. It is the character. Okay, that is the next data type that I want to really talk about. So let me share my screen. All right. So the character data type stores any number, any letter, any space, or a symbol. Any number, letter, space, or a symbol that can be entered in a computer. Okay, and every character that we actually put in a computer, it is going to occupy 1 byte of space. It is going to occupy 1 byte of space. Enough for the talking. Let's come and see some illustration of the same concept. So we are going to actually come to file here. I want us to create a new project. File, I'll go to new, and I'm going to select project. Then when I select project, we need to select empty project, and make sure here C++ is selected. Then down here I'm gonna say okay. Do you want to close project 1? Yes. Save the changes. Yeah. You save if you want to. Again, we need to save this project. I'm going to name it character. I'm going to name it character, and I'm going to click save. Excuse me. Okay, so now we have our editor again here. The same pieces of code. I said I'm going to explain what this is all about much later. Hash include your stream. I want you to follow with me. Sorry. Using namespace std, and we have int main. Then I'm going to open my curly braces. So I want to show you to talk about character. Now character, as we said before, we use character to store either a number. We can store a number, we can store a symbol, you can even store a space. Okay, a number, a symbol, a space. It can be even a letter that can be put in a computer. So to declare a character, we use the keyword car for car. So telling the computer that we want to declare a character. So I can declare character car. Then I say first letter. So maybe the first letter of my name. I'm just going to say first letter. Then I'm going to store the first. Is that how letter is written? I don't know. Okay, whatever. Then I'm going to store in the first letter of my name, T. I'm going to store in T. Now an important thing that you need to know, or rather it can be a little bit a difference between the integer data type and the character data type, is that whenever we are storing a character in a character data type, we put that character in quotation marks. Notice that T is in quotation marks, but notice when we were putting age as 25, we did not use quotation marks. So that is one difference. When you're using the integers, you do not put those numbers in quotation marks, but when you're using characters, you have to put that character in quotation marks. That is one. Number two, with numbers you can do addition, multiplication, subtraction, and everything, but you cannot do those operations with characters. That is another thing you need to know. You cannot do those operations with character. So let's print my first letter, for example. So console out, I'm going to print first letter. I'm going to print first letter. And L, we said, and L is to make sure that our results are printed on a new line. Do not confuse that. If we put another print statement here, then we should have the results printed on a new line. Then of course return 0. I said I'm going to explain about return 0 much later in the course. let's have return 0 there. Then let's run this code. Let's compile and run it. It should be able to print the letter T. It should be able to print the letter T. So let's see. Okay, there is an issue, an issue. What issue is this? There's an error. Let's check the error. There's an error message here. Invalid conversion from constant car to car permissive. Okay. Let me see. Let me see. Let me try using not that single quotation. Just want to see where the issue is. Okay, let me run. I just want to see where the error is coming from. Yeah, okay, sorry. I have seen the issue. Now, when you're using character, you are going to put it in single quotation marks, single quotation marks. So character, the character, okay, should be in single quotes. I'll explain why much later. So let's continue. We are here. So when we this statement, line 8, is printing my character T. But notice, I said there are other operations that you can do with integers that you cannot do with characters. For example, let's try to perform addition. Maybe that is the last letter. Let me have maybe the second letter. Let me just say second letter, and I say my second letter is H. My second letter is H. Then here, let me just try to do operation. Let's say maybe I have initials. I have initials. Let's say the initial could be of type I don't want to use string because I haven't talked about string, but I'm forced to. Let me just say string. Initials, string initials. Then I say first letter plus, just trying to add second letter to first letter, plus second letter. Now I want to print initials. Sorry. I want to print initials. Now if I run this, if I compile and run this, now you see it's giving me an error here. It's giving me an error where I am trying, this is line 9, where I'm trying to add the first letter to the second letter to form the initials. Let's check what error message do we have here. You see it says here, I want you to check here, error, invalid conversion from int to const character. Not that one. Not that one. Let's see. Here's other error message, the most common. Yes, this one. We are trying to convert these variables here from integers to string. You see, so it is error, invalid conversion. There's invalid conversion. Why? We are actually trying to okay, invalid conversion from int to const char, f permissive. Now if we come up here, we are trying to do an operation that can only be done with integers, with character data types. So it gives you an error because such operations cannot be done with character. I was just trying to show you. So we cannot do addition with character. We cannot do we cannot do subtraction. We cannot add two letters. In other words, we cannot add two symbols. We cannot multiply two symbols. So basically, you should be able to see why it's important to actually have data types, because the data types are going to limit you in terms of what type of operations you can do. They're going to limit you in terms of what type of operations you can do. So it's very important that we have data types in place. Okay, for today I'm not going to continue. I'm going to stop there. I am welcoming questions. Ask a question. You turn on your mic, then speak, Rukia. You are speaking and your mic is off. What are you saying? Your mic is still off.
Mimi niko na swali.
Yes.
Iko on side.
Yes?
Let me share my screen.
Okay. Okay.
Let me share my screen. Inaniambia error pia mimi huko.
Oh, it's telling you, it's giving you an error. It's too early to get errors.
Tena yangu ni pale kwa yangu ni pale kwa int.
Share your
Nimesha
screen.
share.
Yeah.
Hapa. This part.
Int main.
Nimesha share.
Your error is coming in line 2, eh? Okay, it's just a simple thing, eh? After std, you're supposed to put a semicolon. After std. After std, using namespace std, you're supposed to put a semicolon after std. Yes. You're supposed to put a semicolon after std. Yes, Tony.
Hapo imeleta error.
Yeah,
Imeleta error nyingine
ikiprintiwa
hapo.
tu ni hivyo.
Hapa kwa.
Yeah, hakuna kitu ingine. You are using capital letters and I used small letters. Hakuna kitu ingine, ni hiyo karatasi tu kama imeprintiwa, I think imebaki kulipa. So nitalipa alafu nikuje niichukue, haina shida. Oh, okay, ni sawa. Ni sawa. Okay. Okay. Si bado ina nini, ina compile. Kwa nini unataka kuikimbiza? See, it's there. Yeah, that's it. Any other question? Stop sharing.
Haya.
Stop sharing unless you have another question. Joshua, are you okay? Mr. Joshua, are you okay?
Yes, sir.
Are you okay? Okay. So let's stop there. Let's stop there. We will meet. We will meet in the coming class. Get ready for your exams. You have exams. Check the timetable. Check the timetable. You have exams. Be ready for the exam. It is for information system analysis and design. Okay, see you.
19th. Nimeona 19th. Sio usiende.
What?
Nitumie record. Nitumie record. Hii record ya hii class.
Good night.
Mimi kwangu sana leo neti imenicheza, nitumie.
Good night.
Haya. Mungu akubariki. Nitumie ticha nawe.